This is part 2 of this mini-series. If you haven't seen part 1, it is linked in the video description below. In this part I'll be doing some further testing on my moldy but boxed C64 to try and get it to work. So without further ado, let's get right to the video. Okay, so I got my working C64 because my donor one didn't work either. Probably because all of the memory chips are missing. And this one is actually the same number of motherboard, 250425. But the funny thing is, this one has this metal RF shield and partly a cardboard one as well. But this one has a metal one. And for some reason someone smeared a lot of thermal compound everywhere. Can't imagine that's from the factory, and I didn't put that there either, so probably some previous owner. But this machine actually works. I use it to play games on all the time. But just so you can see, there we have it. Commodore 64 Basic. So let's swap some chips from this machine to this machine, and unfortunately this one has a lot of chips soldered in, so yeah, can't really test a lot of things, probably only the VIC and the SID. Okay, let's just test those. Let me grab a tiny screwdriver so I can wiggle some chips out. Now, normally I'd use a chip puller for this, but mine gave up the ghost. It broke, and I haven't been able to order a replacement one yet. So just carefully wiggle this VIC out, put it away, and then carefully wiggle this one out as well. I don't really want to remove all the thermal paste from the one that was in here, so I'll just leave it on, but it means I can check what kind of chip it is. The one from the new 64 is a 6569R3. So put that in there. Power it up. Okay, so the VIC is good. Now that can stay in. This one has to come out. Okay, so that's good news, because I don't really know if I have a replacement one for that in my donor machine. So this one is working. Gosh, it's some cheap sockets in. That's funny. These seem to be really cheap sockets, and these seem to be better ones. Can't remember if, well, maybe someone soldered better sockets onto this one, I don't know. Let's see if it's a color RAM, probably not. But it's socketed on both machines, so why not? Just and I actually don't have any other C64s with a lot of socketed chips. I have a C64C, but I know that a lot of the chips in there aren't socketed. They were replaced at some point, not by me but by a previous owner, and for some reason they took all the sockets out. Really don't know why you would do that, but yeah, it happened. Okay, put this color RAM chip in like that. There we go. This one also works fine. Yeah, oh well, these actually seem to be the same sockets. Put that one back in there. Put that one back in here. Okay, so there's not a lot of other chips I can check in this machine, unfortunately. Probably have to build a ZIF64 kind of thing, just like Mr. Black has, so I can test out various chips. I could probably do that with my testing machine, or my parts machine, but for now let's just put this one back together. Huh. It looks like I broke one of the legs of this case, so I have to be repairing that one as well. Well, it saves 3 screws to put it back together, I guess. Okay, so on this machine, this is a 251137 Ref C. There's also not a lot of socketed chips, unfortunately, but this one is socketed. It's just a different version. Well, that's not any good either. Oh, right. No, these are swapped. That's what this is, of course. Yes. Yeah, they swapped some of the chips around on the different board revisions. I remember that now. So it seems I have to resort to other measures. Okay, so slight change of plans, because all the chips in my other Commodores are mostly soldered in. Also, I checked my C64C, and besides most of the chips being soldered in, it's also a shortboard version, so most of the chips aren't even in there. So what I'll try to do now is to just remove all the socketed LCs and push them back in to see if maybe it's just a contact or something. And in the meantime, I can fix this. I can find it right now. I'll probably order 64 pressing rods. Check. 64 pressing rods just to be able to check some other things I can't find. There's parts for this. Or what I can do is unsolder some of the chips in the machine and just socket them. It'll also be easier for future replacing and testing. Just maybe make 6 or 7. It'll be quite nice. Okay, that's all the chips resocketed. Just have to see if that helped at all. Nope, still nothing. Chips aren't heating up as much as they were either. No, there it comes. Yep. Well, could be. Hang on, I need to check something. Okay, so pin 40 here on the CPU is the reset signal, and just ground this somewhere, and this should go low and then high right after power on. So low, high. Okay, so that works. So the reset signal is fine, so the CPU doesn't get reset all the time, which would prevent it from executing any code. And it's 5 volts on there. I could measure VCC on the CPU, which would be pin 6 and ground pin right here. But as the reset line is 5 volts, probably will be fine. 1, 2, 3, 4, 5, 6. Yeah, that's 5 volts. So that's fine. Yes. I could check the data bus to see if anything weird is going on the data lines and see if something might be dragging down the bus and preventing the CPU from executing code. So let's grab the oscilloscope and start checking signals. Okay, so I have my oscilloscope hooked up, and just turn the camera a bit right there. And I'll just start testing the pins on the CPU. I'll start by showing you the reset pin signal. Come on. So it's low, and then it goes high. So that's fine. This is set at 2 volts per centimeter per division. Now the address lines start at pin 7. So this is pin 1. This is pin 40. So it's 1, 2, 3, 4, 5, 6, which is VCC, and pin 7, which is address 0, and then it just goes 0, 1, 2, 3, 4, 5, 6, all the way to 15. 14 and 15 are on this side, for a total of 16 address pins. I have lost my pin count. 1, 2, 3, 4, 5, 6, pin 7. Okay, so that's normal. That's also normal. It's normal. It doesn't seem like it's executing anything. It's definitely not doing anything. That. No, that was just bad contact. Oh. What is... What on earth? Okay, that's definitely not. I mean, this is a normal signal. This is what you would expect. And it's 2 volts per division, so 2, 4 and a bit. 5 volts per division, it's 5 volts. So that's correct, but just these last 4 are... I mean, what's it doing? Okay, well, you can check the clock. That's fine. 1 microsecond per division, so it's 1 cycle, 1 megahertz, so the clock is fine. This is the data out. Whoa. And these are the data lines. So data 0, data 1, data 2, 3, 4, 5, 6, 7. It's fine. Yeah, those address pins don't seem right at all. So I wonder what happens if we remove this PLA chip. It might be a bad PLA, might be bad RAM, might be bad anything else actually. Let's just see what happens. It just goes high. It just jumps to 5 volts and stays there. Ah, that's looking better. This scope is getting a bit old. But yeah, those seem better. So it could be that one is bad. Now, unfortunately, that is also socketed on my other motherboards. So I guess I'll just have to desolder one from my donor Commodore and see if that does the trick, because these tend to fail a lot. I mean, there are even modern alternatives for these. Look up some reviews if you want to. There's a lot of modern alternatives, and these fail a lot. So I'll start unsoldering one from my donor C64 and pop it into this one and see what happens then. Okay, so I got out the soldering iron, it's warmed up. I got my donor board, and this is the chip we want to remove. So I'll just check and put a mark in the middle of it so I know I'm removing the correct one. I really hate if I unsoldered all these pins and it turns out to be the wrong chip. And unfortunately I don't have a heat gun or a fancy solder extractor, so I'll just have to do it the old-fashioned way with a little pump, which is not really the best way to do it, but I don't have any other way. So just add some fresh solder to it, heat up the pin, Alright, there we have it. One chip. And if the camera would autofocus. And as you can see, without lifting any pads or traces. This isn't, of course, isn't the best way to do this, but it's my way to do this, and I have been doing it like this for years now. And it works just fine. As long as you're very, very careful with how much force you put onto the chip. Okay, so this is the one that came out of the machine. This is the one that came out of the working machine, and I know for a fact that it's working because before I started to take it apart for parts it worked fine. Okay, small interruption, something like a hornet just flew in through the window, so don't know where it went. I think I got it. So as I was saying, the machine was working perfectly when I started scavenging it for parts, so I know for a fact that this chip works just fine. Now I hope that these legs are long enough for these cheap sockets. Let's see, it should be put in this way. Seems to be fine. Okay, fingers crossed. There we are. So the machine works. So that's all it was. It was just simply a dead PLA. 906114-01, and those tend to fail quite often. So next, let's reassemble this computer, and I'll just have to get a new PLA, and we'll see what's on the floppy and on the cassette that came with it. Let's see. So I'm tempted to just take these out, but I mean, they're not useful and they're quite annoying when you're working on a machine, but I really like to keep my machines as original as possible. And yeah, that includes having the RF shielding in it, so I'm not sure what I'll do with that. For now it's just gonna stay in there. Reconnect the keyboard and reconnect the power LED. It should just go. That was it. Is that all? Yeah, okay. Okay, so let's see if we can actually type. Yes. Okay. So it was just a PLA. Very, very common failure on these machines. I'm not screwing it back together right now. I need to clean it, and well, that's just easier when it's apart. Let me move the camera a bit here, and we'll turn on the floppy drive again. Don't need my scope anymore. Need that one. So put that in there. Don't need the soldering station anymore. I'll just put that down over there. I do want to get the data set to see what's on there. In fact, let's look at the data set first, see if it works. So load. Oh, that needs some contact cleaner. Wait, what? What the? It ate the cassette. What on earth? Is it? Yeah, the contacts on the motherboard seem really bad as well. probably just turning off the machine and getting some contact cleaner. I know a lot of people like to use deoxit. I haven't found where to buy it in the Netherlands yet, so I just use contact spray. Spray it in. Just plug it in and pull it out a couple of times, and that cleans up the contacts nicely. Leave it to dry for a bit before plugging everything back together, so everything can evaporate. It shouldn't affect anything or short anything out, but if you're using it on, for example, variable resistors, they tend to smoke or catch fire if you don't let them dry. Okay, so we'll have to check the dataset later. We'll just see if the 1541 works. I want to load the index drive 8. That is a whole lot of character. Let's try that again. Okay. Well, it loads what it says on the front of the floppy disk, so it seems to work. Let's see, burning. Whoa. That seems like could be fun. Yeah, okay, I want to check out some other things on here too, so we'll just shut that down, reset the drive, and for this we are going to need a joystick which is tangled up a bit, and grab that and insert it into control port 1, get the final cartridge, and of course that doesn't work. Reset? No. Could be that the cartridge connector is dirty as well. Ah, there we go. So, system basic. Oh right, I forgot what it... Ah, right, burning rubber. So my camera cut out, and I don't really know how much you guys caught of that. But it loaded burning rubber using the final cartridge, so... Ah. Joystick in port 2, right. F1. Oh man, I probably should have read the controls first, but yeah, okay, so it works. Let's try out the cassette board, cassette data set, and see if anything. All right. Oh, it works on. Okay, that's nice. Ah, much better. So let's rewind that all the way. Yeah. There we are. Play. Well, it found something. Load error. Okay. It found something. Okay. I mean, this machine is from 1984, according to the motherboard. So I imagine everything is from 1984. Maybe it's from the early 90s that it got recorded. Something got recorded to tape, but I mean. Oh! Okay. Well, what I was saying, I imagine anything recorded to tape might be long gone, but there's actually something on here. It's basic A. Symmetry is -1, the Y top. You can now do on your calculator. By inputting X top into the formula, I mean, yeah, sure, I saw something funny in here, so I'm gonna. So it says, "What is this, jackass?" Okay, maybe there's more on it. Let's see. Alright, found something. This nothing. Okay, so funny, but everything seems to work. So the computer works, the dataset works, the 1541 works, even the joystick works. Maybe the other joystick won't work, but nah, it'll probably work. So in the next video I'll clean everything up. Some things need some retro brighting. The printer for sure needs some retro brighting. I haven't tested the printer in this video because the ribbon in it is just long gone. It's dried out, and the mechanics itself are dried up, and that thing deserves a whole video in on itself. For now this works, and in the next video, as I said, we'll clean it up. I'll have to look for a different F7, F8 key by the looks of it. The F is missing. But yeah, we fixed it. It was replacing a PLA, and it now works. So awesome. And if you like this content, of course, like, subscribe, hit the notification bell, all that YouTube stuff. And also check out my website, where I post about these things in a lot more detail than I normally do in these videos. So thank you for watching, and I'll see you in the next video.